grade 9 mathematics, and you're here again with me. So yeah, and our last topic for this session is going to be problem solvings with quadratic functions. So we'll have 3 different problems. We will be discussing number problem, business problem, and projectile motion problem. But for our first problem is going to be the number problem. So this is an example of a number problem. The sum of the numbers, the sum of 2 numbers actually is 14. Find the maximum possible product of these 2 numbers. So we know that if you add these 2 numbers, it's going to be 14. So let's label let's label the unknowns first. So we have the first number. So our first number, we'll label it as x, okay, as an unknown. And then our second number, we will label it as 14 minus this unknown number, because the sum of these 2 numbers will give us a 14. So this number minus 14 will be the second number. That's what we know. And then the third number, the third one we want to take note is the maximum possible product. So the maximum product. The max product, I'll label it as the y value. So if we multiply these 2 numbers, we will have a y. So given that formula, let's write it down. Our formula is y is equal to the x times the 14 minus x. So as you can look at it, it's going to be a quadratic formula. So let's try to simplify this. So x will be distributed to these 2 terms. So we have y is equal to 14x negative x squared. So we have a quadratic function. We want to rearrange it. Let's rearrange it to its standard form. So we have y is equal to negative x squared plus 14x. Okay? So we now have this function. Having this function, we can now look for the maximum value. So how do we look for this maximum value? First, we need to remember our vertex formula. Our vertex formula will give us an idea on how we can substitute the values in this format. If you recall, we're looking for the maximum value, and if we're looking for the maximum value, what do we use when we're looking for the parabola? Remember, what is the maximum point or the most minimum point of a parabola? It's actually the vertex, right? So how do we look for the vertex given a standard form? As you recall our lesson before, we will be using the axis of symmetry formula. So to look for the h-intercept, so to look for the h, we will use the axis of symmetry formula, which is the negative b over 2a. Okay, so given this formula, what is a? A is equal to negative 1. What is b? B is equal to 14. And what is c? C is going to be equal to 0. And we will be using it later as we solve for the problem. So we first have to find our x value. So the x value is going to be negative. B is 14. So 14 over 2 times negative 1. So this is going to be our h value. So 14 over negative 2 is going to be 7. So our h value is 7 in this function. Now, given that we have 7 as a function in this function, so we can now use another formula to look for k, connecting it to the vertex. So this formula we will be using is k is equal to 4ac minus b all over 4a. So this is a connection with the formula of the vertex form. Okay, so substituting all of the parts, so we have k is equal to 4 times a, which is negative 1, times c, which is 0, minus b, which is 14, all over 4 times negative 1. Sorry, it's b squared, so we have squared. Okay, so simplifying all of that, we will have negative 196 all over negative 4. And then if we simplify that, k is actually 49. 49. And because k is 49, our vertex for this formula is going to be 7 and 49. 49 being the maximum point of this function, being the maximum point of this function. So what are the first numbers and the second numbers? So the first number is going to be 7. That's our first number. Number is 7. And our second number is going to be 14 minus 7. So the second number is 14 minus 7. So which is also 7. And our maximum number is going to be 49. So we can write it in a statement. Find the maximum possible product of two numbers. So the maximum product of the two numbers. So the maximum product of the two numbers is 49. This is your final answer. And that's how we solve for the number problem. Okay, so we're back again with the different problem now. This time we're dealing with projectile motion problem, as I said a while ago. Our previous problem was number problem, but now we're going to be discussing about the projectile motion. So what's projectile motion? It's like an object is moving in the air at a certain direction, and then we can calculate or estimate the time it will reach the ground or at the time it's at its highest peak using the quadratic formula. So this is an example. A basketball is thrown with an initial vertical velocity of 24 feet per second from a 6 feet above the ground situation. So for example, the person is standing 6 feet above the ground. He's a 6 feet tall man. Then he throws a basketball at a 24 feet per second velocity. So that's how fast the ball is moving. Now, the ball's height in feet is modeled by this equation. So we were able to derive an equation wherein h of t is equal to negative 16 t squared plus 24t plus 6, where t is the time in seconds after the ball is thrown. So we have three questions that we want to find out in this equation. Is find the ball as it strikes the ground. So what time will the ball touch the ground? And then what is the maximum height of that ball? And when will it reach that maximum height? So let's first deal with when the time of the ball strikes the ground. So if you recall, this is a quadratic function, right? So it's a quadratic function. And we know that a is negative, right? A is negative. And what do we call about a being negative? If a is being negative, we have a quadratic function shape that looks like this, right? So we can imagine a ball is being thrown at a vertical velocity and it shapes in this format, right? So because it shapes in this format, the first initial time is here and the next initial time will be here. So if we assume the ground being the x-line, so that means the root 1 or the x-intercept will be the starting and the ending point of the parabola. So that means if we throw a ball from the starting line and where it ends or where it lands will be the next root. So to find the time the ball strikes the ground is actually to find the other root. So we just have to solve for the roots of this equation. If you remember the quadratic formula, where x is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. So using this formula, with this equation where we have a is equal to negative 16, b is equal to 24, and c is equal to 6. So we'll substitute it in this equation because we're solving for a here. We'll substitute it in this equation. So we have x is equal to negative 24 plus minus the square root of 24 squared minus 4 times negative 16 times 6 all over 2 times negative 16. So using our calculators, you can actually find two equations having the plus and the negative version. So the negative version, our first time is going to be negative 0.22. So it starts at negative 0.22. If we graph it, this will be at negative 0.22. And the other root is going to be 1.72. Okay, so 1.72 is the next time, or is the next point. So 1.72 will be here in our graph. So looking at it, it reaches the ending point at the 1.72 seconds. So we now have the answer for the first question. The ball strikes the ground at 1.72 seconds. So that is our first answer in this problem. So what's the second answer? So B, we now have B. B is, what is the maximum height of the ball? So we have the we first have to look for the maximum height of the ball before we can find the maximum time, or when does the ball reach at the maximum height. Okay, so actually these two problems are actually interconnected to each other, because we can again use the formula of our previous lesson, because it's, if we have it in our vertex form, we can use k is equal to 4ac negative b squared all over 4a. So we can use this because the maximum height is the y, and then the maximum height is the y, and the maximum time where it reaches that height, at the time it reaches that height, is actually the axis of symmetry. Okay, so solving for it, so let's substitute the values. Again, where a is negative 16, b is 24, and c is 6. So we will have k is equal to 4 times negative 16 times 6 minus 24 squared all over 4 times 8 negative 16. So if we simplify that using our calculators, we will have an answer of 15. So k being 15. So in this statement, the maximum height is 15 feet. The maximum height, max height, is 15 feet. Okay. And lastly, when does it reach the ball, or when does it reach the ground? So we have the formula for h is equal to negative b over 2a. So we have negative 24 all over negative 2 times negative 16. So we have a maximum height of 0.75. So the time for it to reach its maximum height is 0.75 seconds. So I will write it here. The time for the ball to reach max height is 0.75 seconds. So these are our three answers in solving this projectile motion problem. Okay, so to end our sessions on problem solving, our last problem is going to be this problem for quadratic function. So we have this problem here. A company can earn weekly profit of P pesos, so we'll name P as pesos, by selling items based on the function peso of x is equal to negative 0.5 x squared plus 40x negative 300. The function refers to the number of items being sold. Okay, so how many items, our first question is, how many items does the company need to sell to reach its maximum profit? And then B, what is the maximum profit? Okay, so first off, if we imagine a graph again, if we imagine the product or the function, again it's negative a. So negative a will give us a function that look like this. So we're looking for the maximum point. And what is the maximum point of that function? The maximum point of that function is the vertex, right? The vertex will be the maximum point. So how do we solve for the vertex? Okay, so if we have that graph, if we have a graph like this, this is the number of items over here, number of items, and then this is the profit, because the profit is dependent on the number of items, right? Okay, so going back. So we now know how the graph will look like, and we know the shape of it. So what do we want to find out? Is that we want to find out how much items. So how many items do we need to sell to get this, to get the maximum profit? So based on the number of items, so we're looking for the x coordinates of the vertex, right? The x coordinate. Or simply put it, you're looking for the h. Okay, so we're looking for the h. So what formula do we use for h? So the formula for h is equal to negative b over 2a. So again, we're going to be using that formula. So let's identify what's a, b, and c in the function. So a is negative 0.5, b is positive 40, and c is 300. Okay. So looking at this problem, we just have to substitute it. So we have negative 40 all over 2 times negative 0.5. Okay? So negative 0.5 times 2 will give us a 1, negative 1, and 40. So negative 40 over negative 1, we have 40. So we need to sell 40 items to reach the maximum profit. So the statement will be the company needs to sell 40 items to reach max profit. Okay, that is our first answer. So for our second answer, what is the maximum profit? So again, so what is the point here? The maximum profit will be our k value. So if we have a k value, so we can use the formula of k. So k is going to be, again, same formula, 4ac negative b squared all over 4a. So substitute the values here. So our function is going to, our formula is going to be 4 times negative 0.5 times 300 minus 40 squared all over 4 times negative 0.5. Okay? So solving this equation, if we use it, we use our calculators. At the end, we are going to have k is equal to 500. So this is now our maximum profit. So we have a profit of 500 pesos. So the max profit of the company will be 500 pesos. Okay? So we have these two statements to answer the problem for this function. So That's it in our problem solving, and I'll see you all next time for our fourth quarter sessions.